So the title of this talk is Visual Impairment in Maths and Computing-Based Subjects. I'm Emma Jane Rowlett, and my contract's actually ended, but I was a research assistant at Nottingham Trent University, and I'm also a PhD student at the University of Nottingham. The project that I was involved in with Nottingham Trent was accessibility in MSOR, LaTeX and Braille, and that was with my husband Peter James Rowlett, who's here. And for some reason it says David Wapples. I know what's happened. That should say Michael. It's a long story.
That's some spelling error there.
Yes. And it was funded by the Maths, Stats and Operational Research Network and operated through Nottingham Trent University. My PhD title, the other bit of what I do, is accessing materials, making appropriate and effective reasonable adjustments for print-impaired students in higher education. And my research methods were to look at 4 UK universities and select a gatekeeper from each one, from people I already knew to make it easy. And students and staff were emailed, and in the end 14 students and 28 staff took part in semi-structured interviews. My student case studies were David, a maths-based student, Jim, an ex-maths-based student, undergraduates, both of these, Simon, a computer-based undergraduate, Scott, a computer-based undergraduate, John, postgraduate, sorry, I can't read what I'm doing, John, a computer-based undergraduate, and Steve, a computer-based undergraduate. And I've only just noticed they're all male. Computing and maths, all male. Then I looked at staff, and we have a woman here. We actually have 2 women. So Sheila, a maths support tutor. I've not turned it on the other one, have I? Is it gone now? Yeah. So Sheila, a maths support tutor. James, let's get one.
Go that one. You've got John, Susan.
Oh, here we are. Okay, selected staff. John, Departmental Disability Officer, maths-based. Susan, Disability Service Advisor. Lucy, Disability Support Worker. Mike, a maths-based academic. Sheila, as a maths support tutor. James, a computer-based academic. Eric, 2, Alternative Format Service Manager. And Hazel, a Disability Support Worker. And the reason with Eric 2 is I let people choose their own pseudonyms, and I have several Johns, several Erics, and some other things, so it's a shame. Right, just a very quick overview. I'm going quite fast because I want to get onto the activity. Braille sometimes uses 6 dots and sometimes uses 8, and there's an example there of what a 6 cell looks like and what an 8 cell looks like. There are many incompatible standards exist for mathematical Braille. Some are 6 dots, some are 8 dots, some are all sorts of different things. And the problem was that respondents tended to tell me that either the staff would tell me that students preferred, or the students would tell me they preferred one particular type, and so they'd be all different types. So one university might produce one type of mathematical Braille, and a student say, actually, I read a different type. And that can be quite difficult. This is an example of just standard plain maths Braille, about as plain as it can get. And what we've got at the top is Pythagoras' theorem. H squared equals O squared plus A squared. I should say capital H, capital O, capital A. And underneath is the Braille for that. And in each case, you've got your capital sign, your H, followed by your raised to lowered again, and then the next line's the O, the next line's the equals. So you have to raise and lower again, so it's quite a lot of characters. Oh, my picture's not appeared. Is it there? I've not got it on this one. Right. Although standard Braille is linear, there's also 2D Braille, which maintains the layout, and as you can see, the math symbols are drawn so you can feel the symbols. There are some problems with that, and a lot of people don't read it. And I have got some examples of it over here if you want to have a look, which show the print equivalent and what they've turned it into. There's a couple of maths examples, and there's also an example of computing code turned into 2D Braille. When I spoke to people, they tended to say that not everyone likes, mathematical Braille is not for everyone, this 2D Braille. And David, one of the respondents, said that he was not convinced by 2D Braille, though he thought it would be worth considering for some students. For him, he hadn't learnt it to begin with, and he started his course without knowing it and found that he was too late on to try and learn it. If he'd maybe learnt it in his first year, he might have been okay, but by his third year, although he thought it would be useful, he didn't have time to try and learn it. The problem is, though, unlike standard Braille, which can be written on a Perkins Brailler and other equipment, there's no way for students to write maths in the format that I just showed you. So it does have a disadvantage.
Hang on, was David a student?
Yes, yeah. So large print does not just mean enlarging the print. I mean, some students do manage with work that is photocopy enlarged, but generally for most people that isn't any good. Most users require changes to the spacing, the layout, the font used, and even colours. I mean, for example, how I have mine is very large, spaced out, and all sorts of fancy things, and as I say, bright yellow paper. But that's just me. And sometimes math symbols are too close to distinguish, so you need to add some spacing. And again, have you got the picture? Because I haven't.
Yes.
Right, good. Hazel, a support worker, said, so sometimes you have a fraction times a fraction. The spacing that LaTeX put between those two fractions is sometimes not adequate. You can't see that they're actually 2 multiplied by an invisible multiplication sign. So depending on where you're sitting, you may see that as A over B times C over D, or you may see that as AC over BD. But there is a break in the line, but that isn't always clear to students with visual impairments. Or to anyone, really. Another problem is fonts used for computer code are often difficult to read and may need changing. You probably notice here that the font that I'm using, which is Verdana, and then underneath it says how easy is this to read. That is New Courier. Courier New, I can't remember which. Courier New, I think, which is quite a common computer code font, but it is, as you can see, it's much harder to see.
Is that the same font size?
Yeah, they are the same relative font size, which I think is 36 on this slide. So it comes up smaller to begin with. It's narrower. There's all sorts of differences about it, and a lot of people find it difficult to read. A lot of dyslexic people as well find it harder to read. These fonts are also more difficult to run through optical character recognition software. They don't always show up. Because they're narrower, and depending how big they are. Also, with a lot of textbooks, because they're presenting a lot of computer code, they will actually put it into a smaller font than everything else. So you'll have maybe an appendix with very small font and these computer code, and that just makes things very difficult for people. Sometimes when you're producing large print, it's difficult to maintain the layout. Those who know computer code, it's sort of tabs across the page often, and when you're producing large print, it's difficult to scan that, to get that to stay the same, and to make it look as it should, partly to fitting it on the page, because your lines might overrun and things like that. There's lots of difficulties there. Speech, another way of accessing materials. Synthetic speech can be difficult to concentrate on. I'm going to give you a bit of it in a minute. But the problem is, although human readers are generally better, they're not available all the time, e.g. 3 AM. If you want to study even at a weekend, it can be difficult to get someone to come and read for you at that time. And particularly with maths, speech can be ambiguous. Hazel again said, lecturers realise that sometimes they say completely different things to what they're writing down. So they might say A plus B over C, and that could be A plus B all over C, or that could be A plus stop B over C. It depends. Graphics. Access to complex graphics of any form can be difficult. Even simple graphics can be difficult, but the complex ones are particularly bad. Most respondents used a mixture of describing graphs and providing tactile diagrams. It says depending on complexity, but what I'm going to tell you now is that some people said they do it for simple graphs and some people would do for a harder graph. So it's not the same. Some people said, oh, if it's a simple graph, I'll describe it. And some people said, if it's a simple graph, I'll plot it. And it wasn't the same at all. People did completely different things. And what students said they wanted was completely different. So I'm afraid I can't give you any advice there. Again, you got the picture?
Yep.
Don't know why I haven't. Graphics are drawn or printed, and heat is applied to make the ink rise. So to produce a tactile diagram, you'd have something looking like this, with bold black lines and a Braille font marking the axis and what the line is. And then you'd apply the heat, and the black lines would all raise up, and you can feel them. I'd hoped to have some of those to show you today, but unfortunately I didn't get myself in gear early enough, and it's not arrived. Sarah, a support worker, found that complex graphs, she described simple ones, I think mostly, and then she would plot complex ones. And she said they would need to be plotted onto several tactile diagrams, as these can be difficult to feel. So she would perhaps have a diagram with 4 lines on it, and instead of doing one, as you know, it'd be spaghetti junction, which line's which, she'd plot each one on a separate graph and then do one at the end that was all together. So you feel each line, get familiar with it, and then see it on the final one. But some people, some students in particular, are saying, I don't need a graph, I just need it describing. And then other students are saying, no, I can't imagine it, I need it.
So when you say describing it, how would you describe it?
There's an issue with that. There's all different ways of doing it, and I can't remember who. I want to say the Open University, I think, have produced guidelines on how you describe it. But again, that depends on the student. And one student, I'm not sure if I've got it here or not. No, I haven't. Oh, what have I done now?
Nothing, it's all right.
There we are. All right, it's on this one.
All right, on there.
Right, one student said to me that they find having someone describe graphs is difficult because what the other person sees as important in a graph or anything might not be what they see as important. And you often have people describing graphs who don't actually know the context in which they're doing. So it's very difficult to work out how you describe it. Now sometimes you describe in words, so you might write it down. If all they need to know is you've got a parabola and it sits here and here, and you just tell them that. It depends on what you need to know. Other times some people would actually sit down with the student and perhaps trace it with their finger, or excuse me, I'm going to go off camera now. Or use something like this, which you can buy in art shops, to bend your graph, and then perhaps say point 3 falls here and 5 is here, and they're all different methods. And unfortunately, there's no common way of doing it. But OU, I think it is, have tried to come up with guidelines for describing things like that. And if you'd like them, then I'll try and get them to you.
I mean, Alan, as you know, can't use diagrams like that because he can't feel very much in his fingers.
Yeah. I mean, that's the problem. If you're not a Braille user, you won't get on with this type of diagram. A lot aren't. Now, the beauty of this is that you can still do the curve without the labelling. So, some people can't feel it, but they are. Yeah, they are. This type of diagram, you can actually make the line very thick if you need to for your students, and we've done it quite thick here to show up. And so, even if you're not a Braille user, a lot of people do find that following a diagram and having the points on it marked and described to them is actually helpful from seeing it. But I say other ways, just drawing someone's finger. People have used cardboard. If you've got a bar chart, they've cut out the pieces in cardboard so you can feel the edges of the cardboard. Modelling clay, all sorts of things have been used. Lego, that's another one people have used to describe graphs and charts and all different things to people. I mean, obviously, like if you've got a pie chart, take a circle and cut it up and you can feel the relative sizes. Okay, you'll need telling what the exact size is, but you can get an idea. And it does depend. If someone has had sight in the past, you probably find that they'll pick these things up a little bit easier than if they've never been able to understand what a graph looks like. Moving on to software. MSOR subjects use some specialist software which is not always accessible. And generally what we found is that students will work with a sighted reader to access software programs. But some people have found, particularly postgraduates who've gone on and their course is less prescriptive, they've found alternative software that does work and they've based their work on that. John was totally blind, and he said, John was a support worker for a totally blind student, and he said that for this student, Dreamweaver was doable, There was a screen reader, and also using the code view, which means nothing to me, on the package meant he could pretty easily sort of work out what was going on. He couldn't use Quark Express, primarily because that is purely graphical. Flash he was able to use in terms of the planning of Flash and the storyboarding, even though obviously he couldn't see. He could visualise the process for that, so he was fully involved. XML he was fine with. He was fine with HTML and CSS, and all the languages which obviously had elements of programming about them. I think probably Quark was the only thing that he simply couldn't do. So this student was taking some sort of electronic publishing course, I think, and he did find that most bits he could do and he could work through, although he did need help and he did need sighted people to help him with that. Scott, who was a visually impaired student, said, "I didn't feel that JAWS was keeping up with the technology, screen reader, and a lot of the things that I was doing were involving web pages and Flash is not really the most accessible program to use." That's a bit of an understatement. With the Windows Eyes system, though, they've gone in, basically worked very closely with Microsoft and some of the other developers, so into the point that you can actually update Microsoft Office from their website. So you can, the people who make Windows Eyes a different screen reader, that have more tools for you to make things accessible, and this person moved from using JAWS originally to Windows Eyes and found it more accessible. And that's the problem, is that some screen readers work with some software and some software needs a different screen reader. And again, it's like with Braille, if you only know one, you don't necessarily know how to make the other one work.
Not fully computer with it.
No. Alternative formats. So getting reading lists and lecturers' notes sufficiently in advance was a problem, an age-old problem for any subject. It doesn't matter what subject you're doing. And getting source documents in a format that could be transcribed was particularly difficult, because with something like maths in particular, if you have a PDF file, you can't extract the maths from that. It just becomes gobbledygook. The formatting gets lost. So you might still have x2 equals 3, but what does that mean? Is that x times 2? You know, you have no idea because you lose a lot of the bits. Could have been x over 2. You never know. So that's difficult. And reliable transcription to alternative formats is difficult and needs proofreading. But most places weren't able to provide the proofreading because, particularly if it's turned into Braille, they don't actually understand the Braille. This meant that the students found it difficult to read around the subject and were stuck with very basic notes. One student, I should say, I didn't know if it was on here, but I should say, was actually told that he strictly only needed his lecture notes. And that just wasn't terribly helpful, and he didn't feel that he got the best out of his course because he didn't have the extra materials. On teaching methods, does that come up? Right. Chalk and talk, particularly inaccessible, but unfortunately good for most students. So obviously you don't want to stop writing on the board, and it's difficult. PowerPoint also has its problems. It's not always accessible. For this, you can extract Word from this, but even this presentation, and I've tried to produce this as accessibly as possible, not all the words extracted. I had to go through and take some out for the Word copy. So there is a way of getting the words out of PowerPoint, but the maths doesn't come, the pictures don't come. There's a sound file in this, that's not accessible. So trying to get hold, and as Lindsay knows particularly, PowerPoint is a bit of a nightmare. But what you can help with is advanced lecture notes. If you've written notes for yourself, and get those to students so they can follow what you're doing. If you've got your equations written down that you're going to write on the board, the student can follow that in Braille, large print, on a laptop, whatever, and they can still work out where you are. Unfortunately, it's probably going to be more work, but that's the best I can suggest in terms of making chalk and talk and PowerPoint presentations and lectures as accessible as possible. The main thing to do is avoid pointing and saying this. Here you can see, this you can see, this equation, that sort of thing isn't going to be helpful to the student sitting at the back, let alone someone with a visual impairment. Whatever you do, students may still benefit from extra one-to-one tuition. That might be something you'd provide as a lecturer yourself, or it might be something that the disability support would provide, depending on whether they've got people who are qualified and understand maths. A lot of people did. They had postgraduate students who worked with them and went through the maths. So that's generally what happened. Assessment, extra time in exams and tests. You might need a support worker, and multiple choice questions are more difficult for visually impaired students as there is more reading. So you've got to try and work out what the difference is in A, B, C and D, and that's hard enough without working out which one is actually the right answer.
So not suitable for dyslexic.
No, dyslexic students also have a problem with them.
But they're often
So
considered the easy type of
they're
exam,
often,
aren't they? Yeah.
people think of them as the easy exam. They're often given at the end because they think it'd be easy. And visually impaired and dyslexic students are saying to me, these are my hardest exams, and they are very difficult.
Going on.
Yes, I know there is. Yeah,
For dyslexia.
Yeah.
Yeah.
Some dyslexia.
yeah,
It's a medical school.
yeah.
Can't remember which one.
No, I'm not sure. Extensions to coursework may help, but can cause problems because if you give someone an extension to their coursework, they've probably got an exam the next week. They've still got to revise for that. So you move on into the next extension. So don't know what the answer is. A lot of students said to me they just don't use extensions because they don't find them helpful. If maths is accessed in a non-visual or linear format, such as Braille or speech, this is more difficult to read, understand, manipulate and communicate the answer. I'm going to give you an example of an equation in two linear formats, and I should have said, here's some scrap paper, write down what you're about to hear. Pete, can you, or someone, I don't know if you've got pens. We found a couple of pens, didn't we?
I've got my pencil case.
Ah.
I don't know, I've got much in the way of...
Two buildings and pens and none of them.
A pen or a pencil, something. If you're not a mathematician, I apologise. Although I believe this is statistics. Pete, is this statistics?
Yeah.
We think.
That's all I've got.
Yes. I've got a couple of pens.
Right.
No, it's not mine. It's not.
You're right.
What's happened to my notes? It's not mine.
Right. So everyone ready? This is using Math Player, I think, and it's going to. Here you are.
Square root of fraction sum from I equals 1 to n.
Oh, hang on, I messed up. Do it again.
Sigma equals square root of fraction sum from I equals 1 to n. Open x sub I minus x bar, close square over n minus 1, and fraction, and root.
Would you like to hear that again?
There's a square root in there. Some brackets.
Right, here we go again.
Square root of fraction sum from I equals 1 to n. Open x sub I minus x bar, close square over n minus 1, and fraction, and root.
Right, now, if any of you know LaTeX, I'm going to show you it in LaTeX next, which might make it easier. And this is another way students might have it presented to them, perhaps the LaTeX in Braille or something. That's one way that students sometimes work. And I'm not going to read it out because that would defeat the point. You've just heard it. But the LaTeX is here. And just so you know, I did type it out for Alan, so he would have had it if he'd been here. See if that makes it make any more sense.
Go on, show us it.
Right, ready? Have you got it? Because I don't. I have actually. So did you get this? Did any of you? Pete might have done. He helped write it. You didn't try, right?
Well, the 1 to n, I was fairly sure that when he said 1 to n, it would be the limits on the thing.
Yeah.
The really confusing thing for me about it is there's two sigmas. There's the sigma for the 1 to n and the sigma for the sigma equals.
Upper and lower case.
And so when I heard sigma and I heard 1 to n, I thought it was describing...
Yeah.
Right.
Standard result of the variance.
Yes, I know it.
Yeah.
So
You know.
none of you did get it.
What people often do is they draw the square root, then they start writing, and then they don't know where the square root was supposed to have ended.
Yeah.
Yeah.
And things like that.
It is difficult. And even if you had got it, would you have got it as quickly and as easily as seeing it written down?
No.
And then how would you like to manipulate that?
No.
Using linear formats, using your LaTeX or your speech. And then what if you couldn't write down the answer? What if you just had to imagine the answer? Not easy. So my concluding point, I believe, is that not all students are the same. Supporting students with disabilities means accommodating individual needs, and all students are different. It's often quite useful to talk to the student because They generally, unless you're in the position I was in, which is actually starting education and starting to have trouble with sight then, most students have been through, they've tried doing maths or computing before, and they tend to know what sort of things help them. They tend to have, you know, someone's already tried to describe a graph to them before, and they might have methods that they found useful or whatever. So it's generally useful to talk to the student and see what they think their needs are. Now, there are some references there. I'm going to be very, very bad and not read them out, but if anyone would like them, I'll pass them on. They're just the references for the diagrams. They just show where the diagrams were taken from. And now it's your turn. We've got 20 minutes, but ideally you might want the answers, although perhaps I can email you the answers. But we're going to have a play. Yeah, I mean, anyone who's got to leave, I don't know if anyone's in this room next, but...
I will have to go about 10 to.
Yeah, right. Well, we need this laptop for one of the tasks.
PowerPoint will go on the on-site, will it? Or-
Yeah. Oh, what have I done?
The room's booked 12:30 for 2 hours, so we've not got a room booking problem, so just see how it goes.
Right, so one of the things you need is the laptop. So how many pairs have we got? We need people in pairs. We need, if we can, we need someone to be
4 pairs, yeah.
the sighted person and someone to be the non-sighted person.
Braille, Braille alphabet. This is Braille. What does it say?
All right. Okay. I see that's a Y.
Underneath or around this one?
Yep.
That's kind of how you sort of get it from context. I think, a lot.
Why did not ask another
Yeah.
one?
You need to.
All the ones all combined.
How many of the large lines are 10 degrees and the shorter lines?
Taped over.
Right. Yeah.
Run you, go back to the beginning.
right, yeah.
You should be able to put larger lines and smaller lines.
Oh, right, I see. 20, 30, 40,
Right.
Oh, big.
50,
Is it working? Is it playing up?
60.
One there, that would make Right, you're going to put it on. Blindfold on.
Like when you got tried it.
It's really raised almost.
Okay.
If you feel it, it's slightly bumpy.
Right, there's your thingy with your triangle.
Yeah, little tricks.
This is your
Do the same.
pin. You're going to do that one, are you? That's your pin. All right.
What do you do up to paper?
Right, now I'm going to put the cork underneath it.
Yes.
So you've put it through the middle of the line. That's all right. It's all right. You can do that.
Yeah, and we've got the other thing, not with the bag a little bit.
No, because it's not going to go down far enough. But that's all right.
I don't think we know. Do we?
It's a very rough example.
That'll do. That'll do. So I'm going to line it up. A little bit more. Actually, the line's not quite straight up.
No, I know. I was trying to get some done with a heat embosser, but
Big
it all
ones
got a
and
bit
little
behind,
ones,
so I had
and
to
the big ones are
make
10.
I wouldn't bother measuring all the angles, but you
We
get
haven't.
the idea.
Yeah. What have you got?
780.
Yes. See, it's just this line.
Couldn't even buy any. You don't seem to be able to buy them anymore. The writing boards.
You almost want. I always wonder whether you want these notches to be where there's notches where the lines are.
Notches
Whether-
on the 10.
If they were protrusions, so you could feel around to where the line.
Yeah.
You have to at the moment.
Or if you have notches only on the 10, because you have
Yeah.
got something there, and you
You
just
have,
have
yeah.
notches on the 10,
Yeah.
and then that would
Yeah.
fit, wouldn't
That's
it?
right. You could run your finger around that. I didn't do that. Yes, that's right.
I mean, you can at the moment, but it's just, there's too many.
There's too many.
Yeah.
There's
You
too
need
many
an
for
A4
you to
sheet
be able
of
to
paper.
feel.
Or even if you have a
Paper.
90 and the
There you go.
45 mark, and you could
You're going
work
to make
back.
a paper error
Because
claim.
to be honest, when I got to 70, I
Okay,
thought,
but
well,
I have to tell you how to
Yeah,
do it.
you
I have
should
the instructions
have,
here.
don't worry, you should have counted from
Okay,
there. I
down the
expected you
back.
did it a
Fold
few
the
times,
paper
that's what you
Yeah.
do.
along the
Yeah.
longest
When you
side.
got used
So
to it.
once you get used to it, you can
Yeah.
do it from there. Yeah. And Pete was a bit nervous about me giving you pens because you're giving people blindfolds
Now
and
at one
pens.
end.
Is that a good combination?
Oh yeah, health and safety with that,
Exactly.
you'd be in big trouble.
One end to the corner.
Yeah, I bought it from the RNOV.
Yeah, keep it
Doesn't come with
closed.
a warning about the pens.
Fold it again.
I've got to
How you
go,
do
sorry.
this,
Yeah,
do it
that's
like
all
that.
right.
You'll have to do
Yeah,
it.
that's all right.
You'll have to do it with him and
Yeah.
give me the
Corner,
blind person.
not where it's folded.
He can be the
He's
blind
got to
person.
be the blind
corner.
person.
No,
You
no.
need to fold it. No, you need to fold it from there
Oh, my,
down to
no
the
memory
crease.
at all. There was an envelope, wasn't there?
Yeah, where you folded it before.
No, it's
So you
going to
need
be
to
handy
take
because
the
it's
corner.
bringing things, you know,
That corner
I've got to
there,
think about it
fold
again
Yeah.
for this. And I'm
Yeah,
sure
like that, but the other
I
way.
will be after you and Pete for
So you need to close it again. And then
helping
grab,
advice.
just
every
grab
now
the top
and
sheet.
Oh, they've got the, I like this.
Yeah, and fold that corner as you were before, 45 degrees. Yeah.
I'll go and get my instructions for this one. It's turned itself off, helpfully.
Okay, so just
Come on.
close the sheet again.
Please
You
wake
just
up.
want to pull the corner up, not the whole sheet.
Oh, you want me to
So,
log
yeah, that's
on
it, that's it, perfect. Okay, that's it, and you need to push it back and do that on both sides.
No, it's
Yeah,
speaking.
perfect.
I had a bit of trouble with this, so I'm hoping it's done that. Oh yes, there we go. Can you hear that?
Yeah.
Right.
Right,
Hang on,
now,
blindfold.
just keep it as
Oh
you
no,
are
sim
now,
specs.
where
You
your
have
right
sim
thumb
specs.
is.
That
You
goes
need
over,
to
you know, and then that
pick
sort of
up,
clips at the
fold
back.
up the top
Hold it in
sheet.
place.
That's it, and up to the edge. Yeah, perfect.
How fast do they do it? I went to a Indian evening yesterday. I was wearing sari.
Oh right, you're having a good week. Trouble with, and if you do, I'll help you with them because I happen to know where they are. I'm just going to get my instructions.
Hold the wings out.
Can't read the one I've given you.
You need to do it from the centre of the nose.
Box 3. Box 3.
Of the nose, up to the centre of the back.
Those keys. Not Windows keys.
From the nose. You need
No,
to
over one, it's that one. Right, so if you press that,
fold it all the way along, right down the centre.
right, and if you're now, yeah, I can probably try and turn it up a little bit. It's a bit difficult with everyone else working. I should have bought more pairs of headphones. Right, and if you press P,
Yeah, but all the way down to the nose.
right, that has opened the programs menu. Now, for some reason, it doesn't read programs, it starts telling you what's under it. But if you press I once,
Don't fold at the back. Stop folding at the nose.
right, and now again,
Just let go.
right, that's Internet Explorer, that's what you want. So if you press enter, this will take you to my website homepage, hopefully. Yes, it's opening up. Now it's going to read everything that's at the top here.
To go down towards the nose. The crease is the fold. The fold, yeah. So instead of it being straight and parallel to the bottom,
Right, I think it's stopped now.
it's going to go
Right.
right up the centre.
Okay, so this is the Accessing Materials homepage. And now how you navigate, the simplest way is to work from link to link. I don't know if you know any of this. Yeah, with tabs. And if you need to go back, shift tab. Right, so what I want you to do,
You see,
that's shift,
what I was
and then
trying to
tab
say
is there. Right, and what I want you to find is resources.
So you see, you had it like that. Instead of holding it like that, you have to fold it like this. You see. Oh, yeah, that's what I was trying to say.
Enter, yeah. It says insert, but enter does it as well. I'm not even sure where insert is. Right, so that's taken you to the resources page. Now this time you need to find talks, presentations and posters, which is going to be a bit further along.
Oh, there's another one.
Yeah.
You are right as far as you've got.
So,
That would be.
But you find out that the awareness of why because there
Yeah, that £2.
the trick is to get someone to use an American name.
Yeah, I suddenly thought.
So if you press FN and then the other, that should start reading. There we go.
Sources greater than talks, presentations,
And you're after the date the Elms talk was given.
Accessing materials navigation left, bracket skip to content right bracket, main navigation home about resources news contact, AccessMSOR, search resources section resources, publications, talks, presentations and posters, university work, useful set resources, latest news, set column, the 4th of October 2008 new resources added more column, the 15th of September 2008 website updated new talks and presentations free column, the 9th of May 2008 AccessMSOR working group view news, other upcoming talks presentations and posters paper accepted invited talk 30th October 2008-LMS-E-learning in mathematical subjects talk at Nottingham Trent University.
That's today's one. So we need to keep.
Alright, or you should push it. Look, this one's better.
5 and 1/2 plus 7 and 7.
You need to keep it at a certain stage.
What?
Yeah.
The best is
Alright, okay. Yeah. Because this one would be
Right, to stop it talking, if you press FN and the semicolon again. It should stop. Yeah.
Try and do it.
No, but if I click
yeah, it starts reading again, yeah.
Or if I would have to use this one, would need something and then...
Probably try and go to the link, yeah, try to go to the link, see if you press the back It's a bit tricky and there are, to be honest, I'm only learning it now, I'm struggling myself. This is super over, which this is version 9 and version 10 has just come out. Unfortunately, the people that are teaching me only have version 6. So it's very difficult.
Oh, it isn't like error, is it?
I don't think so. I think that's why she stopped at 8, not 9.
Oops, that's just...
I'm thinking about how.
Read the text without a make.
Sorry, I haven't made it very clear. Listening to it alone, calculate. Sorry. No, sorry.
Or not.
The second question is comfortably.
Oh no, I'm not using my glasses.
Okay, if so, can you read the footnotes?
There's footnotes. If any of you know LaTeX or something to suggest a better way of enlarging it, please get in touch.
Try the magnifiers.
By sheet and then didn't get around to it.
Well, and are able to suggest a better way of enlarging text, please let me know. I have been told that this is that has been explored in recent math something.
Try the higher level of magnification.
Okie doke.
If you're struggling.
The same again, just press it over.
No, that one you lift up. And where you lift it, it just depends, move it about till it's clearer. Either way should do it. Use it in either hand.
Casting shadow.
Yep. That's why you get illuminating magnifiers, but I haven't got one yet. Oh, there's my...
Oh, okay.
So it should be getting bigger.
But different magnifiers look different, so you do find some are easier than others.
This is an issue that has been explored in something still to maths. Was that M1? Still can't do that. But I have yet to look into this. Still got it wrong.
Yeah.
Okay.
But it's quite funny, it's different styles, and then she's got an electronic one, she's not But it distorts, the more it magnifies, the more it distorts, so you don't necessarily find the bigger one. Just try and read the first paragraph.
Yeah, like that, but you just need the one side. Because it's in half, you've got both sides.
Which is cool.
Just need one of the sides.
Well, so stupid, I'm so fucking stupid, I don't know how to make a paper plane.
It's interesting though, because you don't think different font sizes should be the same.
Okay, do the same on the other side.
Yeah, yeah, do the other side.
But you can see the difference, because this one starts here and this one carries on to another.
Oh, bother.
This one's a quick one. This is one of the ones that's supposed to go with.
Okay, and then it said you put a pin in it.
A pin, and actually, I forgot, but you put that over the pin, so it fits round that hole.
Like that?
Yeah.
So so I'm going to give you a pin.
Oh dear.
Take it between your finger like that so you don't stab yourself. Put the pin in the corner.
You might find it easy to put the bit of thing underneath to make sure the pin stays. That's what Lindsay was doing, and it worked quite well. But you have to try and get the bit of what's it out in the first place.
Okay,
so you might want to put that under your table, which is caught under the piece of paper. So.
Very good. Very well.
There you go.
Okay, there.
Yep. So that sorry, I've taken it off. So put that around it, and then there's a thing that goes over the pin and around the corner.
Do you need another one?
Is it in line with the bottom line of the angle?
Box 3.
Put this over your pin.
Oh, hang on.
That goes over the pin to lock the
Hang on, at the beginning.
Start button, press space bar to press.
That kind of.
Yeah. So then make sure that the bottom edge of the protractor is in line with the bottom edge there, right?
Sorry about the wavy lines.
Right.
And then that's where you need to be. So how many dots round is that?
Now we've got 1, 2, 3, 4, 5, 7, 8, 9.
So how many degrees?
Is that 9 or? That would be 45.
I think so, yeah.
Yep.
Well, I know the internal, just about 180 divided by 3. Is it 180?
Right.
Right.
You try for a different triangle if you
No.
like.
Oh, okay.
You have to pull your pin out your piece of paper.
Okay, right. There you go.
Because you're right, that is a fairly
Yeah, it went wrong.
triangle.
It started as a 40-50 triangle when I first started drawing it, and ended up 45-45.
Oh, that's right, it's a nice introduction.
What have we got here?
That one's not great either. I need to do some better ones.
Feels more like a right angle.
You don't always have to pick that angle, you can pick a different angle if you
Let's
like.
choose the one that's nearly.
Because it does mean moving it a different way around.
Make my job a little easier. Apart from the counting.
Okay.
Is that into cork? It's desk or cork? Which way is it? That's the right way, I'm guessing. Oh, thanks.
You can take your blindfold off to see if it flies. We won't make it work out if it flies. Yeah? We should have competitions for the best paper aeroplane. Right. What haven't you had? This one. Have you had the magnifiers? You had counting. You have, haven't you? Not counting. That one, the money one. No?
you want it, it's called talks, presentations.
So we're talking 95 degrees.
Okay. Take your blindfold.
Close, was it?
Your dot wasn't quite in the middle and you think it juts out 5 degrees. It's actually a 90 degree. You were right.
Oh, is it 90?
With your person back there, yeah.
Yeah, on this case. Earplugs?
Yes, well done.
Is that everything?
I know, it's the thing I got stuck on originally. Oh, it's a mobile.
Mobile. Cool. Everything?
Oh. Is there something small in it? This is just like...
I did ask suggestively.
You did ask suggestively. I think that's cheating.
And that's certainly cheating.
Someone might have pinched
Hold on, you're not supposed to look. Did you look in there? The next question is, what colour is the book?
Oh, I know, got a clue how I'm meant to know that.
That's the point. And what is the title of the book?
Oh, it is raised?
Yeah.
Not that I can read that. But...
No.
The Happy Bunny. The Happy Little Bunny. And
there was a penny in there.
Yeah.
There was a penny unless someone's had it.
No, it's still there.
Right, it's coming. Got it? Yeah. Okay. So, remember you're listening out for accessing materials, common problems experienced by visually impaired users. And you've just got to give it a date. So we'll just stop. Do you want to start playing again?
You're supposed to be not. Stop it. For you, it's to have Yes. Fold the short end.
Yeah, very good.
So leave it folding out.
Alright, to get to...
£5 is what I got there, and it's very small.
I didn't see that. I didn't see that before. The one penny's got something like this.
Right. Fold down the new fold you've printed to the original fold. So fold it against the middle. So leave it alright and fold over. Yeah.
Oh, we haven't done...
Yeah.
Now throw, it says. Hit Carly, very good.
Oh,